The objective in this lab is to analyze an object moving with constant velocity. A model explaining the observed behavior is constructed using Newton's second law. My example is a table tennis ball rolled on a table. The ball would slow down eventually due to rolling friction and air resistance, so I am choosing a short segment where the ball is in near constant velocity. Point masses were placed in the center of the ball or system in each frame, so the distance traveled by each frame could be calculated. The ball is 0.04 meters in diameter, as shown by the measurement of the calibration stick. The center of the axis is at the center of the system in the first frame, or time 0, and the ball moves in the negative direction along the x-axis. I built a model based on Newton's second law. The parameters for my use of this law are the initial velocity, the ball mass, the force on the ball, which I set to 0, and the change in time, or delta t. Based on these parameter inputs, my model computes the ball's position plotted against time. The predicted ball positions in red agree quite closely with the observed positions in blue from tracker. The tiny discrepancies can be put down to imperfections in the ball and the leveling of the table that it is rolled on. Another source of experimental error comes from the manual placement of the point masses in the exact center of the ball in tracker. Here is a picture of the forces acting on the ball: gravity, the reaction of the table on the ball, and the resultant force from friction and air resistance. Assuming that the friction and air resistance are very small, there is no net force in the ball. Thus, the ball is at a state of constant velocity.